All right, in question 7, we are attempting to identify the hybridization for anything other than the hydrogens in the molecule. Now, while in general chemistry you learned sp, sp2, sp3, sp3d, and sp3d2, for the overwhelming majority of organic compounds, sp3d and sp3d2 don't really come into play. The only time they really come into play is if we have something in the third row. And given that most organic compounds are made up of second row elements, and especially this molecule is all second row elements with the exception of hydrogen being in the first row, we know the d orbitals don't come into play at all. So what's the easiest way to identify these? Well, usually an sp3 atom, and I'll designate those in yellow, is going to be an atom that has no pi bonds. We find sp2 with one pi bond, and sp when we have two pi bonds. So we'll designate the sp2 with green, and we'll use this blue color for sp. So now it just becomes a matter of looking at our molecule and finding the appropriate groups. So we can see here, as well as here, we have carbons that have two pi bonds, so those will be sp. But also here in the middle, this carbon, it has double bonds, but because it has two double bonds, that means it has two pi bonds. And both of those pi bonds, having both of them, will make it sp as well. Now, any atom that contains just one double bond, because that's the only way we can have one pi bond, is going to be sp2. So that includes this nitrogen, this carbon, the oxygen, and that carbon. And then any atoms that have no pi bonds are going to be sp3. And so that's the rest of our atoms. Oh, let me go back because I missed two of the sp2 carbons, which are these two that are on the double bond.